everyone. Today we have our another new episode and we will discuss on the nanotechnology. We have our world famous speaker, Professor David Smith, Dr. Tamanna, and my colleague, Mr. Mustafizur Rahman. Professor David Smith, because of subject matter expert, I want to invite you on discussion on nanotechnology. I just get message. Mr. Jason also joined into the sessions. Professor David Smith.
Well, Sharif, thank you. Nanotechnology is a broad term that covers really the manipulation of matter at a nanoscale. And a nanoscale is about from 1 to 100 nanometers in size. Uh, in some ways, it's kind of hard to comprehend that, but it really is beginning to get closer to what we see are the basic building blocks of everything the world is made up of. Uh, Nanotechnology has applications in many, many different fields, such as electronics, medicine, energy, materials, uh, many others. Uh, but also nanotechnology and how we're seeing nanotechnology applied, particularly in early stage science today and others, is it's creating new phenomena and new properties that are not really observed in some of the larger scale building blocks we use and things. You're seeing quantum effects and increased surface areas having dramatic effects as you look at nanotechnology and how it's being used. Uh, According to some of the market research that I've seen, uh, the global nanotechnology market size was valued at around $70 billion US in 2022. And it is expected to grow at a compound annual growth rate of about 30% between now and 2030. So that's a very good compound growth rate in this area that's really very dominated by science and pushing the limits of science. Um, the Richard Smiley, when he was at Rice, a friend of mine there, was one of the leaders in building some of the early nanotechnology technologies and the blocks and other things like that which have set the foundation for where we see nanotechnology today. Some of the major factors, though, that we see driving the market growth and the increased emphasis on nanotechnology is for nanoscale devices and particularly nanoscale sensors. Uh, and so this is creating a lot more money in the marketplace for research and development. And we're seeing many, many publications, many papers uh, of the growing awareness of the potential benefits that this nanotechnology can bring to all different areas of the world and what it can be do. Now, there's many different types of nanotechnology, and it really depends on the size, shape, structure, and function of not only the nanotechnology, the nanomaterials, and the nanodevices, but some of these are even being proposed to do extremely large scale projects uh, with some of the smaller devices we can use. So, for example, carbon nanotubes, which are cylinder type of structures, which is what Smiley invented at Rice, they're made of carbon atoms that are stronger than steel, and yet they're more flexible than rubber. And some of these carbon nanotubes have actually been proposed to do things like building a space elevator out of nanotechnology carbon nanotubes. They're being used in spacecraft. They're being used in developing advanced aerospace materials and others. Another place where you're seeing nanotechnology is an area called nanomedicine, which uses nanoscale particles and devices to diagnose, treat, and really prevent uh, a disease. Another area, which again goes back into my background, having led the first semiconductor roadmap, is in nanoelectronics, which uses nanoscale components and circuits to create faster, smaller, and more efficient devices. This type of nanotechnology could bring us back to a place where the tenets of Moore's law of doubling in power and computing for semiconductor chips will continue into the future if we're able to take care of and benefit from the scale of nanoelectronics uh, and be able to do it. One of the other benefits of nano electronics is using traditional CMOS technology, for example, in uh, central processing chips, the CPUs, generates a lot of heat. And one of the side benefits of using a carbon-based nanoelectronics and some others is it dispenses heat much more effectively than the noble materials we typically use today. Now, to be able to take advantage of this, and Sharif, I know you always want me to cover this, is it's a great area for research in universities today. It's a great area for entrepreneurship, as long as you have investors for entrepreneurship that are patient investors, because development time is still pretty long in this one.
Thank you,
So,
Professor Desmond.
one last thing, Sharif, to work in this area, you need a strong background in science, mathematics, and engineering. And those are some of the key things you need to be successful.
Thank you. We have another subject matter expert, Mr. Jason. He's the CEO of Ageless. Mr. Jason, what you want to discuss about nanotechnology?
Thanks, Sharif. Appreciate it. Um, yeah, nanotechnology. It's a fascinating subject. Um, what is nanotechnology? Really, it's engineering things that are less than 100 nanometers. So it's very, very small. Um, we're actually built out of small cells and things that are even smaller than cells. So we already have a good example of nanotechnology um, in on our bodies and in our brains and our hearts. Very, very small components that are utilizing the physics, chemistry, and biology that nature has provided. So it's a good example of nanotechnology that has been designed not necessarily by humans, but by evolution itself. And now what scientists are doing is they're building uh, more components that are on the same size. So just recently, they were able to build some small, I think they called them some kind of small robots to some degree, but small objects that can move around on their own. And those nanobots or biobots or whatever the terminology can actually navigate a complex environment, and that's what makes them so powerful. So, figuring out how they navigate their world is something a wide area of research, and I think is what really what we need to understand more. It's hard for a lot of people or biologists or um, different people to really think about something that small having intelligence. Um, but at the end of the day, when you put two, say, proteins in two different environments and it reacts differently, it is to some degree intelligent. Because what is intelligence? It's the ability to accomplish a task by different means, multiple means. And so I think these nano engineered systems will have a certain degree of intellect. Obviously not the same as a human brain or even a dog brain, but they will have to be able to navigate an environment. Of course, those are dynamic nano engineered systems. There's also static ones. There's a lot of areas in material science and other fields that utilize nano engineering principles to build, say, stronger materials that are much stronger than anything nature could build on its own. So it's kind of two areas of nano engineering. Right now, we're kind of right now we have things like nanoparticles for delivery systems. If we're talking about drug delivery, as an example, you can target specific tissues with nanoparticles. So those, aren't going to be as advanced as we really need. That we'll see in, say, the 2030s, that can actually navigate these environments and do more complex tasks, say in the human body, um, or for cleaning up the environment, or different use cases. Um, but it's a fascinating field, mostly because it's at the intersection of several interdisciplinary areas, and it really takes advantage of the physics, chemistry, and biology of our world. And so that's kind of a broad overview. I think it's definitely amazing, and thanks, Sharif, for having me on.
Thank you. Dr. Tamanna, in terms of research and innovations, as you are academician, if you share your views, uh, I had the same question for Mustafizur Rahman after Dr. Tamanna. Dr. Tamanna, what you want to discuss about research and innovation?
Yeah. Actually, Dr. Sharif, I mean, as both my panelists have further only spoken about it, it was in 1959, by Richard Feynman, the first uh, entry into the whole field was started, and the term nanotechnology was actually coined by Professor Nario Taniguchi, and so the scanning microscope scope was first made possible during his time. This and then the invention of atomic force microscope made it possible for nanotechnology to start. Now, nanotechnology, like as far as I'm concerned, as a political scientist, it is of varied use. So I mean, health, for example, in India is a major concern. And if nanotechnology is used in a big way, it can really help solve many of the problems. So, for example, nanotech detectors for heart attacks. I mean, if the hospitals were using it, it would be much easier. The ambulances should be, because it's a matter of fraction. You might just get you might just die, and so these technologies have to be there. Then in the arteries, chemotherapy, uh, surgeries, eye surgeries, it would be required. Regulating blood sugar levels, because India and South Asia has a major problem of blood pressure and sugar, insulin problem. So I guess there nanotechnology can be majorly used. Then nanoparticles for drug delivery to the brain, or therapeutic treatment of neurological disorders. So new diseases are coming up, due to you might say environmental pollution, or your lifestyle problems. I guess nanotechnology can majorly help in this particular regard. Then DNA sequencing, that is what is there. Then cancer cells in the bloodstreams. So then secondly, I would like to point out, the government is majorly concerned, and as we have also been discussing in other our previous programs, that energy. So solar paints or photovoltaic paints can replace solar panels. Applying solar paints to any surface will enable it to capture energy from the sun and transform it into electricity. This can be used in houses as well as cars. Then wind power generations, nano generators. These are flexible, thin sheets which can be bent and generate potential power. The nano batteries and other things, which would be of much use. These are used to help rechargeable lithium ion batteries late longer. Now, then another area, because we India, for example, is agrarian based, so is China. We are agrarian based societies, and so nano fertilizers are ones which could really help uh, agrarian societies, and South Asian countries are relying a lot for their economy on agriculture, for example. Hybrid polymers are used in packaging and to reduce spoilage. then sensors for blood-borne pathogens, nano emulations to reduce bacteria on produce, and nanoparticles based on titanium dioxide using as antimicrobial agents. So fertilizers being used in a certain way. Now, uh, uh, in India, for example, research and work on nanotechnology started in 2001, and with the formation of the Nanoscience and Technology Initiative with initial funding of rupees 60 crores. So India needs to invest heavily in nanotechnology, because you have it can be used in every sphere. I mean, the social scientists too are really concerned about it, and we need to not just concentrate on biology, chemistry, or physics, but also social scientists have to concentrate on this, so that a better system can be developed, because scientists have a different way of looking at things, and social scientists have a different way of looking at things. So I guess together they together can be able to form bring up situations which would be much helpful for countries to develop, especially the developing countries, where we need money. And I mean, there should be a transfer of um, uh, there should be a transfer of technology between the nations. The developed world should share their knowledge with the developing world of Africa or Southeast Asia, etc., so that they can too develop these technologies and have the best possible solution to health issues and agrarian issues, as well as the science based issues. And these should be taught to students from the age of, when they're just when they're children, so that by the time they're like they reach their senior secondary, they're able to understand the concepts and contribute to the nation's and the world's knowledge. Thank you.
Thank you, Mr. Mustafizur Rahman. What you want to discuss about R&D part of nanotechnology?
Okay, thank you, Dr. Sharif. As Dr. Tamanna clearly mentioned about the research and innovation in India, I want to say something about Bangladesh perspective. As an economist, I think in the context of nanotechnology in Bangladesh, the potential for research and innovation is substantial, particularly given the country's growing focus on technology and development. This is much more important. I want to discuss about some point like agricultural innovation. So Bangladesh, with and its agrarian economy, can benefit immensely from nanotechnology in improving crop yields, pest controls, other things. And health is much more important sector. Another thing is research can focus on fertilizers and pesticide as well. And environment friendly nanopesticides and fertilizers are important. Another thing is in case of healthcare and medicine, as Dr. Tamanna mentioned earlier, there is a vast potential for innovation in drug delivery system. Targeted cancer therapies and rapid diagnosis tools can be used. Research in nanomaterials can lead more effective for in the given challenges of water pollution and in Bangladesh, nanotechnology can play a crucial role in case of research and innovation. Research can focus on developing effects like nanofilters, nanomaterials, and remove contaminants from the water. That is one issue. And another thing is, Bangladesh is much more case of industry. So creating materials that like a more durable, much you need much more focus on textile industry, because Bangladesh is a growing nation, and in case of textile and in this sector is much more important for economic sustainability. So main durable, stain resistance, and have novel properties, uh, and UV protection and antibacterial features can help in case of textile industry research. If I told about in a discussion, I told about the energy sector, and now I want to tell in here about the energy sector. Uh, Research in nanotechnology can significantly impact in the energy sector, particularly in solar and battery technology. This includes developing more solar panel energy use, and we can increase more potential renewable energy uses. And Bangladesh demand for energy in Bangladesh is increasing day by day, so we can meet the demand by introduce this. Environmental remediation is much more important. As you know, research can also focus on using nanotechnology for environmental cleanup, such as removing heavy materials and pollutants from soil and water, which is a significant issue many parts of Bangladesh. Another thing is educational and educational research and infrastructure development. This is much more important in investing in nanotechnology. Educational research and infrastructure is much more crucial. This involves setting a specialized nanotechnology research center, can be promoted, and promotion with collaboration. As I mentioned, always the institutional collaboration, and moreover, international institutes fostering culture and innovation, and among young scientists and researchers is much more important. Again, one last things is encouraging private public partnership, encouraging private public partnership and collaboration with the government, academia, and industry can accelerate the research and innovation. It includes funding and projects of nanotechnology, facilitating technologies, and other transfer from the industry and academia. So I think these are the vital. This can play a vital and crucial role in case of research and development of nanotechnology. Thank you.
Thank you, Professor David Smith. Are you with me? Okay, now I want to give chance Mr. Jason. Mr. Jason, as we are discussing about nanotechnology, if you give us some sort of industrial innovation, especially from Silicon Valley and from California. I think you are right now in California, right?
Yes, I'm in Los Angeles.
Yeah. If you share some of your experience, industrial experience from California, is there any research happening in this nanotechnology area?
There is. Really, it's happening not only in California, but it's happening all over the globe, as you're seeing. It's really a revolution, similar to how the Industrial Revolution occurred a while back. We're basically inventing new tools to alter matter to some degree. And we think about what is something that we may have in the future down the road. We could, on some level, have a machine that could create anything. Say a device that just sits on your desk. You push a button, and it just, similar to 3D printing, but much more granular, much more accurate. It just prints out, say, a piece of steak or a vegetable or whatever you want, or an iPhone, let's just say. Now, while that's out of the scope of what we can currently do, there's nothing in the laws of physics that says that that's not possible. In terms of what's happening today in California, in the U.S., a lot of it's still R&D, but there are starting to be a lot more commercialization of these products and services in the nanotechnology space. So manufacturing things, 3D printing, pulling in new technologies from there, and really being able to analyze things on the nanoscale, like single cell analysis, and that's something that's rather new in the broad scheme of things. But so there's all these applications, whether it's drug delivery, whether it's manufacturing, material science, whether it's building, say, something that can interact with biology. For example, in genetic engineering, you could use some form of nanotechnology to alter cells, as an example use case. And so, think of a technology like CRISPR technology, where they can actually go in to a piece of DNA and they can actually take a snippet and they can edit that DNA. I would say that's sort of a basic form of nanotechnology, because you're altering something that's very, very small. The width of the DNA actually is about, I think it's about 2 nanometers. So it's very, very small. And so applications like that, I'm most interested in the ones related to aging and biology in general. But they go beyond just that application to, like I said, whether you're, say you're needing to make a material that could have water, go across the surface and not necessarily make you be absorbed. For example, say you have a T-shirt that has this special material. In theory, that T-shirt could be waterproof. And so it's applications like this that I think a lot of inventors and entrepreneurs in the U.S. and California have their eyes on and are innovating on it, essentially. But yeah, nearly so many universities, though, they have nano engineering departments. And for me, I started looking into it years ago. I actually got into the nano engineering program at UC San Diego originally, even though I ended up changing my path. They were the first university actually to, or at least the first UC to actually have a nano engineering bachelor's degree. And this was, say, about a decade ago. So it's come a long way since there, and I think we're still in the early stages. I think there's a few key enabling technologies that still need to be invented to actually see the fruition of the power of nanotechnology. In particular, there's a field called quantum biology, where we're really learning about these effects of biology on the quantum level. And I believe there are these quantum effects, essentially. And once we get a better grasp and understanding of what's actually happening, we'll be able to engineer devices that leverage both quantum biology and nanotechnology to see things that really are right out of science fiction. I give the example of a handheld device, say the size of your cell phone, that could heal a wound. As you know, if you get a cut, right, say you get a cut on your hand, that cut does heal, but it takes a while to heal. So you could imagine a small device that could heal that wound very quickly. So it's a combination. It would be a combination of tools, but having nanotechnology as one thing you can leverage is going to be very powerful. And so there's a lot more. There's a lot more happening, especially at these universities. It seems like, if you look at what's happening at Stanford and MIT, and their research, it's literally things out of science fiction. So it's quite amazing. But yeah, I hope that helps, Sharif.
Thank you, Professor David Smith. You are from industry and you have heavily involvement with technology industry. So how we can improve this area, nanotechnology research and innovation?
Well, Sharif, great question. And the answer is much like what Jason was saying, but let me take and expand it a little bit broader, and particularly into some developing nation modes there. if I look at nanotechnology in developing countries, it's a really a great focus area for researchers, for policymakers, and other type of stakeholders. I love that Jason mentioned the quantum biology here because that is an area where I personally see tremendous opportunities for innovation and for wealth creation going forward in solving some of the more difficult problems. But some of the countries really are it can, as I said, provide some of the most innovative solutions for some of the most pressing problems I see in uh, developing nations, such as water purification, disease diagnostic, and treatments, food security, food production, renewable energy, many other areas that where developing nations have needs that are in some instances different than what we have in developed nations. Uh, Nanotechnology can also create new opportunities for economic growth, industry development, and social welfare. And you can even take this nanotechnology and trace it back to the United Nations SDGs, the Sustainable Development Goals. And the nanotechnology, particularly in the developing world, can directly apply to that. Now, there are challenges there. Some of them are in risk for some of the developing nations with nanotechnology, such as ethical, social, environmental, and health issues. Uh, and just like many other new advanced technologies, nanotechnology can also create new inequalities and dependencies and conflicts between countries and regions. One of the places that really has to be put in place to take advantage of developing advanced nanotechnology is you have to have adequate infrastructure, particularly the science infrastructure, the regulatory education, public engagement to really advance it there. And there are some significant regulatory and legal impacts of nanotechnology, as it is a very complex and evolving issue that involves many stakeholders, such as governments, industry, researchers, consumers, and actually the civilian population as well. So there needs to be a clear and consistent definition of what is nanomaterials, what is nanotechnology, and how do you classify these. As as such, it's been kind of open field, so to speak, on it. You need to also see the development of appropriate standards, guidelines, and regulations to ensure the safety and efficacy of nanotechnology products, particularly those going into healthcare and agriculture and some of the others. But you also need to have regulations in place to protect the environment and other parts of it. Um, you need a transparent governance framework that can be applied globally. Right now, if you look at the regulatory activities, these are all regional and in many times conflict with other ones around the world. So you need a transparent and inclusive governance framework in place. You need to see uh, that nanotechnology is pushing some of the limits of intellectual property law and how this needs to be done to be adequately uh, developed in products globally. And those are some of the issues, Sharif, I think that are there. Some of them that particularly affect the developing nations. And again, like in many of these areas that we talk about on your programs, there are regulatory issues, educational issues, and all of these have to be done not just on a local region, but really a global region to enable this technology have its full impact.
Thank you. Dr. Tamanna, what you want to discuss about this policy development for nanotechnology?
Yes, Dr. Sharif, what I feel is that gender mainstreaming is extremely important. The policymakers worldwide have to see how in STEM, how women and diversity of people from LGBTQ or the queer population and transgenders, they are included, because that is called empowerment. If science has less women or people from other communities, other diversities, that is a huge problem. So strengthening gender mainstreaming at the very outset is extremely important. Then include diversity from the very outset. From the small age, girls have to be encouraged. There's a way of encouraging children. If you kind of have the whole thing that the girl is going to play with dolls and the boys are going to play with machines, that is extremely problematic, because it hinders women, children, girl child to in inculcate in herself a scientific spirit. So I guess somewhere that is the whole thing. And it is a two-way communication system. So the government and the society and the NGOs have to come together. I mean, women scientists have to train the young children, how to understand what is science and how to appropriately use it as they grow up, and become scientists in their own field of choice. And nanotechnology especially, because it's an upcoming field. Earlier it was much lesser in pace, but now, because of be it medicines, be it agriculture, be it anything, it's a major push which is being given by world over. And what we need is, so policy recommendations could be like strengthening gender mainstreaming, then including diversity from the very outset, then adopt a strategic engagement, visualize future application in everyday life context. Everyday life, science can be used. And so how to sharpen the brains of little ones who are going to witness the world as we move along. And and discrimination of women in STEM technologies has to be reduced by major ways. So as women take on more leadership and advancing changes, women's contribution to industrial transformations occurring specifically within the energy sector should be considered. So energy is another area where women can contribute in a big way. And medicine, for example, as doctors and surgeons, for example, and the use of nanotechnology there, is of crucial importance. And nanotechnology is one of the most promising technologies as of now, which touches nearly every aspect of our lives and has the potential to significantly impact our society in different fields. So, and that is the whole thing. And women can do a lot for in nanotechnology, but only if they are given chance. The problem with science, and science is where, if diversity is allowed of these communities, uh, chances of, because 50% of women or more than that are of women who are in are in on earth right now, and if they are not given the encouragement to enter into science and mathematics, I mean, these are the areas which need women more and more represented in the whole structure of science. So till that time, women will not be empowered, and women empowerment requires education in science in a big way. And there should be an interaction between social sciences and the natural sciences. So I mean, nanotechnology is not supposed to be reduced just to certain scientists. It has to be broadened in its base, because different subjects can add dimensions to the nanotechnology which others could not. So we should not relegate other subjects to a situation where they cannot contribute to nanotechnology. I mean, so as AI, etc., women as well as social scientists have to interact and enter into the whole structure of sciences, and make it a better way of looking through the world. And yeah, that's all.
Thank you, Mr. Mustafizur Rahman. How we can train the young community for these skills?
Yes, absolutely. This is a good question. Young community. This is actually is it's a policy matters. Um, um, uh, the government support is much more important. The government policy and funding is much more important. I think you can establish dedicated funding for nanotechnology research and development, and develop national technology policies that outline clear goals and strategies can be introduced. As David clearly mentioned, the inclusive governance is much more important, and it can play important role in this sense. Create incentives for the private sector investment, as you mentioned about the youth empowerment. So young people are thinking about the entrepreneurship, but they are not aware of the excess of fund. So invest in the excess of fund information is much more crucial in this case. So infrastructure development is much more important. Establish nanotechnology and innovation parks, foster research and development, and commercialization is important. Another thing is when you are mentioned about youth and young community, education and workforce training is much more important. Bangladesh and South Asia is now um, um, crossing in demographic dividend. So integrate nanotechnology education and in the university curriculum, including interdisciplinary courses, and combine nanotechnology with other field. Organizing training programs and industry professionalism is much more important. Promote STEM, science, technology, engineering, and mathematics is much more important. And another thing is research and development, as I mentioned earlier. There is a lot of regulatory framework develop, comprehensive regulation and safe handling of these products and processes. And most of the important thing is public awareness and engagement. Conduct public awareness and awareness campaigns to educate general population about the benefits and safety aspects of nanotechnology. Engage community leadership can enhance young generation in much more interaction with nanotechnology and other things. Again, academic and industrial collaboration and commercialization is much more important. Support a startup and a small business developing nanotechnology product is much more important. Promote platform and showcasing a nanotechnology market product based product is much more important. International collaboration, as I mentioned, the foreign direct investment in case of nanotechnology is important. When you are starting with a startup, a foreign direct investment is automatically is there, and it foster the economic growth. Adaptation to local needs, it's another point. Focus research and development efforts of solving local problems and addressing local issues by the young generation is much more economically appropriate for Bangladesh. Again, environmental safety and other issues are there. So by addressing these areas comprehensively, Bangladesh can significantly advance its capabilities in nanotechnology, leading to sustainable development and economic growth. It will require collaboration among government bodies, educational institution, industry, industry, and international community. Thank you.
Thank you. Thank you. Professor David Smith, what is the closing remarks for today's sessions? Or if you have any strategic advice for Bangladesh, for India?
Well, Sharif, thank you again for allowing me to be part of this. As we said before, nanotechnology has many, many potential applications and domains, such as medicine, energy, electronics, materials, and more. All areas which Bangladesh and other developing nations need to really be part of. Uh, but if I look at some of the current and future trends where we see it, uh, it was mentioned earlier about nanobots, which these are tiny machines that can perform tasks at molecular level, such as delivering drugs, repairing tissues, assembling other nanomaterials and things. Great opportunities for developing nations and science in there. Another technology in nanotechnology is graphene, which is a atomic, one atom thick layer of carbon that has really some of the most remarkable properties I've seen in ages, such as high strength flexibility, very conductive, and transparency. And it can be used as a sensor, a transistor, a battery, coating, many, many applications. This is an area that would be very easy for developing countries to get into. It was discussed by Jason about nanomedicine, and I discussed nanomedicine. Tremendous opportunities in there to use nanoscale particles and devices to diagnose, treat, and prevent diseases such as cancer, Alzheimer's, and diabetes. And nanotechnology and nanomedicine can also enhance the capability of human body in areas such as vision and cognition and others. And again, I talked about nanoelectronics earlier, which is using nanoscale components and circuits to create faster, smaller, more efficient devices such as computers, smartphones, and sensors, and also enable a lot of new functionality uh, and great opportunities for developing nations and developed nations in this area, because nanoelectronics will enable new functions such as quantum computing, nanomorphic computing, and spintronics as ways to build the future and create the future. And what is really good for you and your colleagues with this, Sharif, is the playing field for this is wide open. And with adequate infrastructure, uh, any place in the world can take and seize these opportunities and jump in and be a market leader going forward. And it will set up the opportunities for enhanced collaboration, enhanced economic development, and really set a collaborative environment in place that can be used to advance the country, the institution globally. So, Dr. Sharif, thank you for, again, allowing me to be part of today's program.
Thank you. Thank you for your excellent contribution. Dr. Tamanna, what's your closing remarks for today's session?
Here I just wanted to add that there is a lot of connection between religion and nanotechnology. In the science fiction Halo, it was discussed. It was told that a panel of Muslim scholars discussed a strip of bacon made by molecular assembler, a device capable of producing the meat directly from individual atoms instead of slicing it from an animal. All meat from a pig is forbidden according to Islam in Islam's halal laws. Synthetic bacon is identical to the real one, but it has never been part of the living pig. So, the story may look like a joke, but it shows how the capacity of nanotechnology to manipulate atoms may change the material world in such a way as to raise religious questions. And it has been found out through a 2009 study that, the more religious a country, the lesser it's going to want to accept nanotechnology in their own country. So until now, religions had been remarkably silent on nanotechnology. Nothing compared to harsh bioethical controversies about in vitro fertilization in the Catholic world, for example. So nanotechnology is a heterogeneous body of science and technologies few faith communities have enough universities or journals to examine such a complicated issue, and their attention may be attracted if some dramatic event happens, for example, like the cure for cancer or anything, or environmental disaster. But so I guess there are many things which for example, faith communities are prepared to debate on nanotechnology. So I guess somewhere, religions are themselves going to debate about this nanotechnology. And so I guess people across the realm of religions, as well as politicians and the scientists, have to need to come together and discuss this issue, and let not religion stop from developing nanotechnology. Thank you.
Thank you, Mr. Mustafizur Rahman. What's your closing remarks for today?
Yeah, thank you. I think, as Dr. Tamanna mentioned, religion has not much more conflict about the technology and developing of a nation. And need to collaborate, and people are much more up to date in this regards. I think they will much more up to date. So in the last part, I want to looking forward. The nanotechnology has the potential to significantly impact various key sectors in Bangladesh, as I mentioned, including healthcare, agriculture, treatment, and textile, with the right support and resources. This technology could lead groundbreaking advancement, contributing economic development and improvement of quality of life. In closing, while challenges are remain and challenges are there, as the discussion mentioned, the future of nanotechnology in Bangladesh is promising. Absolutely, there is no doubt. But uh, continued focus on development, education, and ethical practices in this field will be essential to fully realize its potential benefit. I think all agree with me. Thank you.
Thank you. Thank you everyone for joining today's session. You know that World Talent Economy Forum working as a institutions, uh, and definitely we love to work as a business incubation for industrial development purpose. Those who want to collaborate for nanotechnology research, you can collaborate with us, and we publish lot of research paper. And anybody who want to join and like share their abstract, they can share or they can present their research outcome in our discussions. And definitely we want to develop more startup and startup ecosystem. We have many famous people like Professor David Smith, and young and talented people like Mustafizur Rahman, and knowledgeable women like Dr. Tamanna. So hopefully all of our contributions will be effective for emerging economy. I request all of our audience, please share our content as much as possible with the government agency, corporation, and academia. And I request all of our speakers, please share our content and make a meaningful contribution for the global community. This is completely like open source mode, so anybody can join. It's completely free, and we can develop a high quality startup ecosystem with modern science, engineering, and ecosystem. Thank you everyone for joining today's session. Thank you. Bye bye and take care.